Recording. Okay. Like I was saying, you know, these are all shaders, right? So the difference between a shader and a texture, so there's Fong E, there's Lambert. Like I said, there's Blinn in here somewhere. There's Blinn. Okay, so remember what I said previously, that one of the things that is created by default when you open up a new Maya scene is like a Lambert shader just to put on the objects, right? So a shader is a whole, it's sort of a whole piece of code that will create a whole object, whereas a texture or some of these other things that we talked about last week only produce like either color or, you know, a checkered pattern or all those kind of things, like paper essentially. You know, it's just material almost, right? You have to put it on an object and put it inside of a shader to get anything out of it. A shader tells the rendering engine, you know, how exactly, like, you know, where things should get dark, where things should be light, you know, how light hits the surface, blah, 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 all that stuff. So long story short is, you know, when you go to make your shaders, as long as you're using Arnold, now keep in mind, you know, you may not use Arnold for the rest of your life and probably won't. It's the best one that we've got here at our disposal, and, you know, it's what we're talking a lot about. So the difference isn't huge, but you want to use the right shader for the right job, you know. So if we were using, like I said, a different rendering engine, they may have their own like super duper shader that works the best, and you would use that, you know. So like I said, you know, and Arnold actually has a few different ones itself. So if I come down here and I'm in the Arnold area, so I'm going to roll up these guys. So I'm in the Arnold area and I click on shader, you see I get flat, I get mix shader, all these other things. The standard surface is what we've been talking a lot about, because the standard surface will give you almost everything you need to make most types of surfaces, right? So, you know, like I said, there's all these other ones that you switch, there's two-sided, there's, you know, all this other stuff. Wireframe will actually give you like a wireframey looking object, you know. You know, there's effects and things like that. See, so it actually exposes the wireframe, you know, how you've seen that kind of effect or whatever. So anyways, some people hit issues in that they're wondering why they couldn't get certain looks out of the shader, and when you dug into it, we were, you know, there was a Blinn on there or something like that. Because if you go into surface up here in the Maya ones, the Maya area, okay, there's nothing stopping you from dragging a Blinn in here, but you'll see all your, you know, you're getting like color, a transparency, an ambient color, incandescence, meaning like giving off light, a shine color, blah, 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 you know. So, and then that's it. And then it can be reflected. Whereas with Arnold, even though there's sort of page after page of options, it's really powerful and it's really accurate and it does a lot of great stuff. So, you know, while we're using this rendering engine, when you go to make a new surface, you know, reach for an Arnold, the standard shader, and you'll be a lot happier. Renders will run faster, they'll look better, all that good stuff. Some of these models, you know, Blinn and things like that, were literally, you know, written 30, 40 years ago. They're old, they're outdated, they're not very realistic, and you know, they practically should be torn out of here, and you wouldn't even see them, you know. So okay, so that was one issue that, like I said, I saw in some of the last bit of assignments that we did. The other thing I wanted to talk about real quick too, and we didn't talk about this, and we should have, and I didn't, is some people were getting issues when they were saving their files about they were getting dark images. They weren't getting what they saw on the screen. They weren't getting in their saved images, and that's because in the Maya frame buffer, which we talked about, where a rendered picture goes and just is stored in a buffer. The way it's showing you the picture versus the way it's going to save the picture, believe it or not, it can be two different things, right? And there's a few different reasons why I would want to do this, and it's really almost not important, because, you know, there's ways to view film images, you know, literally things that are going to go out to film, things that are going to go to different, ways to be edited, that you want to view it in those, what they call color spaces, right? Long story short is, you know, for our usage here, this is where you control how your image would be seen, okay? And you see all these different types, you know, These are about gammas, which are the way different monitors show things. Like a TV shows things differently than a computer monitor shows things, and this is a film gamma and blah 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 blah. So, long story short is if you stay in sRGB, you'll pretty much get what you're looking at out of a saved file into your saved files. Okay, but only when you do this. Well, let me do a quick render so I have something to save. Yeah, this, like I said, this was the problem that people saw before. So when you go to File and you go to Save, so by default, the save mode is raw image. You see this here, and that's what I'm talking about. That strips out the what's called color management or gamma correction that's being done to show it to you on the screen. Okay, that's the default of Maya, and that's not what you want. You want color corrected image. You only want to you only need to click that once, and from now on it'll be fine. So you'll see, let's see, no gamma. Okay, and then I'll save it again, and I'll turn my gamma back on. So gamma and color management are in this instance pretty much synonymous, so you don't have to worry. So here's no gamma, so that's not the way I was looking at it on the screen. And then this is what this is what I saw when I was in my frame buffer. So like I said, this is something that a lot of people hit, and you just got to change it once, and don't worry about it. It's I saw. This is my fault. I didn't tell you about that. So if you had images that were saved and you were wondering why the hell they look so dark and and everything, that's why. And all you gotta do is click that once and make sure that you're in sRGB, and you're pretty much gonna get what you see. What you see is what you get out of the frame buffer. Okay. So like I said, sorry about that. That was my bad. So the next thing we want to talk about a little bit is some of the issues that people had with rendering times and speeds, and wondering why their laptop was sort of choking on some of the stuff that we were doing. And this goes back to all the things that Arnold, I think I told you at the start, is Arnold has a lot of stuff going on, that it's taking care of for you for the most part, that you sort of that we're not really aware of yet, and we'll dig into that a little bit more. But long story short is, if you're having problems with rendering times on your laptop and wondering why you're not getting the same image times, getting images back as quick as you are here, is just that there's a lot of computation going on here, like a lot. And basically Arnold by default has all the bells and whistles turned on. It's bouncing light around the scene. It's there's a lot of things that are costly render wise that Arnold is just sort of doing because it's assuming that you have a pretty decent machine in front of you, and depending on your laptop maybe you do, but it's easy to choke your renderer and like I said, and wonder why you aren't getting the speeds that you're getting in class. So the best thing to do is if you're getting those problems is to set things up, maybe do smaller renders like we talked about, where you go into your rendering setup, right, and and change your your size. So this is 5. Cutting down. Keep going. Like if things are still choky, you can still get an idea and change. Oops. So if I go to HD 540 and I say maybe 700 pixels across, oh, I didn't save that. So I'll get a smaller render, but I still get so as small as you can get and still sort of see what see your image, the better. Like you just why am I getting squishies?
So that's just the width and the height. It's not gonna affect the quality of the
No, exactly. Nope. That's all in these tweaks here, which we'll get to. And crap. And you can play with these if you're really choking at home. If you want to jump ahead, this is where this stuff is handled in the sampling area of the Arnold. This is the render Arnold Render tab. If you mess with these, or I like I said, I would read up on them. We'll get to them when we come back around to some of this optimization. But if you turn some of this stuff down, you'll get sort of a less quality renderer, but you'll get it back a lot quicker. Okay, so that's a way to do it. But I mean, the easiest way, frankly, is just to turn your size down. Is just to just knock it down to something that you can live with and sort of see what you're doing, but also not choking your machine. Okay. Like I said, a lot of these things, these features that it has are really great, but they're at a really high computational cost, and some of them are weren't even possible 10 years ago. Just having lights that are nice and soft and everything, have soft shadows was kind of a big deal, like I said, 15 years ago or 10 years ago or something, and now being able to bounce all this light around off of objects is it's computationally expensive. So that's why you're hitting that, and either you got a couple of choices, bop your resolution down, go, jump ahead and learn about how to sort of lower your quality, or come into school to get on a higher power machine, or buy a higher power machine is also an option, I suppose. So some people hit that, and that's just what that is, and we'll get into some of that today, because we're gonna talk about some of the options that you have in your materials, and sort of once again the expense that they sort of incur. Okay, so yeah, like I said before, we talked previously, we talked a little bit about Arnold surfaces and the options that go through there. So we're going to go through more of them and how they relate to sort of the spectrum of materials. Okay, and a while back, I drew that really lousy picture about how there are you have surfaces, and there's light that comes in, and it either goes off, ricochets off, or it actually disperses inside the there's light rays that go through an object, there's light rays that bounce off an object, and there's light rays that actually disperse inside of an object. And that's some of the stuff we're going to talk about today, and how to sort of and do that, or sort of set up that spectrum of materials. Okay, so what I've got here is shader samples, that aren't made, because we're going to make them right now, that run from high reflection, or from low reflection, almost no reflection, to very, very high reflection. Okay, your chrome's on the other end. Then we're going to talk about objects that are transparent and or translucent, sort of in this direction. Okay, so the objects that we're going to talk about right here at the front have almost, plastic does. Depending on the type of surface, they can have very little translucence or transparency. Okay, so I've actually went out and I got a bunch of pictures here. So on the far end here is things like paper, okay, and plaster and things like that. Things that have so little reflection that you'd swear that they pretty much don't. Okay, so these are the ones that have that you put just a taste of reflection in, but turn it way down, and it's very, very diffused. Okay, so if we open up our Hypershade, and I'm going to make a new shader here. Okay, I'm going to grab an Arnold shader, the standard surface. Okay, so by default up here, I'm getting this shiny, so by default, Maya shows up with 0.1 roughness. Okay, so when using that, you see you still get a lot of reflection on these objects. So remember, the first was your base color, so we'll turn that completely down. So we have no base color mixed in there, and we have specular. Now specular, in this instance in Arnold, is the same as reflection. Okay, and reflection can be anything from something that's very diffused, but it's reflecting light at you, to something like completely reflective, like, you know, if I put 6 in there, I get, you know, pretty much I get chrome, okay? So believe it or not, I mean, these are pretty much the same thing. If you look here, you see how, like, you know, right here there's this, if you sort of squint your eyes or just sort of imagine this, you can see that there's, you know, there's something more going on here. And granted, it may be sort of facing the light more, you know, if you imagine however they lit this, there's probably a light above this and everything, because you can see sort of where the shadow's going. It's probably pretty diffused, but, you know, this area is obviously brighter than this area. It's not, you know, it's not like plaster, like chalk. You know how you look at like a, you know, piece of chalk and there's almost absolutely nothing going on, because the surface is so rough, you know, at the sort of like micro level that just every ray is going boop, 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 you know, and bouncing in every single direction, versus like most of it coming this direction and some of it going that way. Okay, shiny objects, like, you know, go boom and they go like that pretty much, you know, like they bounce light, you know, and this literally has to do with like the you know, the microscopic level of the surface. You know, if you zoom in, you know, this is a magnifying glass or a scanning electron microscope. Okay, you know, you're looking at, you know, no surface is 100%, you know, perfectly flat. You know, every surface has, you know, little tiny micro, you know, whatever you want to call it, a micro surface, right? So when light comes in, you know, it hits these things and goes like that, and hits the next one, and depending on the angle goes like that. Just like, you know, any mirror, it's going to bounce 90 degrees off of that surface, right? So if a surface is made of, you know, like I said, you know, mostly little tiny imperfections, it's going to appear mostly reflective, right? If it's like, you know, like this at that level, and that's what chalk and these kind of things are, and paper, you know, the light is just scattering in every direction. You know, if you think of like, I mean, it's almost like if you thought of like a disco ball, right? And, you know, a disco ball is like a series of little tiny mirrors, right? Well, if you think of a disco ball with almost an unlimited amount of little tiny mirrors, you know, and they are all aligned perfectly, right? You know, on the ball, it would look perfectly shiny, right? Because you wouldn't be able to tell where the mirrors end and things like that. But if you imagine the surface that's, you know, those little mirrors are a little off and a little rotated here and a little rotated there, it's going to pick up light from different sources, okay? So that's probably the, you know, easiest way to explain it, you know? So if you think of a micro mirrored disco ball, which I don't, you know, you would get those kind of imperfections, you know? So it's all about, you know, how that light goes off of there, and that's what we're simulating. That's what we're simulating with this roughness and how much is bouncing off too. So we have you know, two parts to this. We have several parts to this. I shouldn't say that. So we have weight and how it's mixed into the surface with the other pieces of the surface, the components, you know, the base color and things like that. The roughness, which if I turn all the way up, you see I get that, you know, complete roughness that looks like chalk. So that's 100% roughness. That means, you know, reflecting in pretty much every random angle, and that's why you get this super chalky surface, right? So it, you know, where you place your roughness on this scale really makes a huge difference, you know. And it's, you know, it's like I said, it's kind of a bit of an art form to sort of tweak it. So anyway, so if I come back here and I look at my paper, like I said, I mean, the contribution of what you would think is probably a reflection in both of these is pretty low. I mean, that's probably light bounced off of this versus reflection, maybe a little bit here. So anyways, long story short is you could crank this way up, maybe maybe to the point where you see this, I got a little bit of highlight there, but it's diffused all over the place. I'm going to bring this down a little bit, and then you would just bring your color in, you know, because it's mostly white. Maybe even, oops. No, I'll just keep it white. I'll just call it white paper, no tint or anything like that. So you see here, so, I mean, if you look, I don't know what it looks like on your monitor, but on mine, it's like, you know, it's as you would expect, it's very diffuse, but it's got just the tiniest bit of shine there, just the tiniest bit. Now, also keep in mind that there's obviously paper that they make that's incredibly shiny. There's paper that's there's like, if you look at the other underside of wrapping paper, it's always really shiny, so you would bump that up. So, these are just sort of basic starting points of average paper and average this and average that. So, there are always exceptions, but like I said, here we're just talking about sort of the basic concept. So if I drag that on there, that was middle mouse button, drag the surface on there. I got my first one, so I got my paper or chalky ass surfaces like this, okay? If we move on down the line, we've got things like cloth, okay? And just like any of these other surfaces, like, cloth has a range, they obviously make, gold lame that are completely shiny, and they make, burlap sacks that are almost not shiny. So in this instance, we're just going to kind of like play the middle and look at things like, I guess this is like felt or something. So you can see what's going on here. I mean, you can see a sheen that's going on this surface, right? It's quite diffuse, but not incredibly diffuse. All right. And the main surface is very rough, and it's very, it's not, you don't get hard shadows or anything like that. So the main surface is very rough, and the shine, depending on which color, like the red seems a bit less, and so does the black, but this green is actually pretty shiny. You got to just look at, take a look at what you're trying to make, This is like maybe one of those little wiping cloths. So this is, kind of satiny and shiny. I think these were sheets of some sort. A lot of shine here. So you look here, and you've got almost none, but there is some. You see where it's facing the light, there's just a little bit going on, so that like you could go in there and put just a tiny amount in, and depending on what you're trying to do. So like a nylon, you see what you got here. It's sort of lightly mixed in, fairly shiny. Okay, so I'll just make something somewhere in the middle here. So I'll get a fresh Hypershade. And so I'm not going to worry too much about texture here. I'm just really talking today about both these surfaces, and so I'm just going to put it on there. Oh man, bummer. This thing always docks out. There it goes. Okay. Okay, so notice I'm not naming these things. So, okay, so I'm just gonna just to make life easier, I'm gonna turn down machine is choky again. Hold on, what happened? Please hold. Okay, there we go. This is why I should be naming my things. Okay, so I'm going to drag it on there. Okay. So yeah, so for setting up your shine, like I said, the quickest way is definitely just to push your base color down, so that all you're looking at is the coat or the sheen that's going to go on there, the specular reflection. Okay. So you're going to get your default. You're going to get this medium shiny. So if I was going to go for something, I got some denim here somewhere. So denim is another, decent one here, and that there's almost, that's not a lot of shine. There's a little there, a little there. Okay, I'll go back to this one. So you can see, if you look at this, so this is a good example in that, there's a little bit going on, but not a ton. The undercolor is definitely, it's obviously like a black. But most of this is being, since it's not colored, you can sort of really see exactly what the shine is doing here, because without color, you wouldn't, or without the shine, you wouldn't see anything here. This is all done with the sheen for the most part, right? So I would bring this up, bring your roughness up, and you guys have two monitors, so you can see two at the same time. So you see here why it's good to sort of get that first, because when you're just trying to mix it into your base color, it's sort of deceptive, right? You know, by bringing your weight of your base color down, okay, without having to disrupt your color because it's still there, you can tweak this until you get to a point that you like it. So if I look here, so, you know, I'm trying to get these two sheens. So, you know, if I had to make another coat of this, you know, color, then I would know that the sheen that goes on top of it is right. All I'd have to do is change the color or whatever. You know, in this instance, I probably just take a little bit of black so that it has some base color, because it's not exactly black. You know, bump it up a little bit, and then just mix that back in there. And that's pretty good. So you see what I'm saying? You know, like so many surfaces are made, you know, are you know, not made through their use of the sheen that comes off of them, you know, the reflection that comes off of them. So, you know, this one might be a little bit shiny still. Yeah.
So when you were like mixing in the base color, does that like is that I don't know, I guess like it seems like it has a pretty major effect.
It's literally like a layer. I mean, like the way that Arnold is set up. I mean, you're literally saying, you know, you're literally saying like, you know, put like, this is my shine layer, this is my surface layer, or my base. Okay, this is my specular. Okay, this is my base, and then there's other ones. There's transparency, or transmission they call it, and there's actually another one called subsurface scattering, which we'll talk about all those. So you can say 0, 0, 0, 0, and you'll get absolutely nothing black, right? The beauty of this is it's just like in Photoshop, where you know how you can say, like, if I had 5 layers here, I can mess with the opacity. This is essentially what you're doing. So if I filled, you know, this layer with a solid, like if this was my base layer color, and then this was my reflection color, I'm literally going like this. I'm saying mix it in like that. That's what the weight does.
Oh,
okay. Yeah, and in theory, I've never found this to be true, but in theory, to be sort of physically correct, these numbers are only supposed to add up to 1, but I've never found that to be true. I just mix it in as I feel like it. So yeah, you can take that, or that's what I've heard, but I've never found that to be true. So, but the beauty is like I said, it allows you to take that out of there and then mix it back in after you sort of get that component set up. And that's one of the beauties of the Arnold shader, is that you're not usually you would have to put that to black to get that to stop contributing to the color, okay, which is you know, that's kind of a bummer. Okay, so we'll call that one our medium shiny cloth. And like I said, there's a whole range, obviously, of you know, cloth finishes that you'd see. Even just in the pictures that I have here, there's a huge variance. You know, there's from that to this to this to, you know, these two guys, right? But on the whole, they're somewhere in the very rough spectrum. You know, this guy I've set to 0.46, and I think it may be a little shiny still. Maybe it'll come up a little more. Pull the weight of that down to see it. Yeah, maybe that's closer. You know, and it's just kind of eyeballing that. So okay, so that's sort of in the middle there, and like I said, I'll keep that one. And then we move on to something like rubber, okay? And so, you know, and just like everything else, rubber comes in all different, you know, sheens, as you see here, right? You know, like this, all the way to these like pucks that are really, like, these are interesting because they're like cutouts or something like that. So they're all kind of all over the place. They're like, you know, pretty shiny to not shiny and all that stuff. And then this is a rabbit looking at a tire, which I thought was awesome, so I kept it. I couldn't pass that one up on Google Images. And let me tell you something, like going out and looking up photos for skin, like, do not Google skin. Like, unless you want to know about like the things that can go wrong with skin, don't go Google skin because it is rough. Yeah, it's rough. Yeah, it's bad. Like I'm not even going to get into it. So anyways, so like I said, what we're talking about here is just something down the middle. You know, what you think of as rubber, you know, being somewhere in here. So you obviously see that the sheen starts to go up, the reflectiveness often starts to go up as you know, like the tread on, you know, this is a good example of different roughnesses on the same object here, where, you know, where a brand new tire has the sheen underneath, right, that very, very shiny parts where it hasn't been, but the other parts that have either been tested or hit the road are much less rough, right? This is why you map things. Remember, we talked last week about, you know, putting, you know, being able to plug things in there. That this would be a perfect example of where you would want to map the roughness value, where you would want these little valleys to be shinier and the top areas to be a lot less shiny, right? So you would, you know, use a method to, you know, change those values. Okay. So let's see. We'll talk about one of these. I think these are pretty good because these are kind of raw rubber. So if you look at this one, you see we've got a decent shine here, decent shine there. You know, so the big takeaway here, I would say also though, is look at how, you know, in every instance it's messed up. You know, it's not clean. It's not, you know, it doesn't have, you know, it's not like any of these other objects. Let's move forward, like that are pretty clean in their reflection, right? So what we do in this instance, like to make life easy or easy-ish, is I'm going to start a new one. I should be naming these, so I'll name this one. So okay, so we'll come in here and we'll call this rubber. So, and I'm going to turn my weight way down, okay? And then being black, it's, you know, it's practically halfway there anyways. So we'll just start, you know, bringing the roughness up here, right? Just tweaking it up until we're, you know, we're going to call this kind of clean rubber, okay? So that number is somewhere, just like the coat, somewhere in the halfway mark, maybe even come down a little bit for cleaner rubber. So we're getting, you know, decent reflections. You know, we're getting a nice little reflection here. Maybe we'll go. Don't forget, you know, you have these other scenarios to check things out. So yeah, so we get a nice sheen. Yep. Check out the exteriors. That's not bad. I'm going to bring my index of refraction up a little bit to get a little bit more on it. Okay. Oop, too much. Come back down. Okay, so like once again, so this is decent from a, you know, the amount of sheen and amount of shine that you got on there. I'm going to throw it on this guy right there. Okay. But once again, it's perfect, right? So this is a perfect example. You know, of course you can go in and, you know, use painting methods and all that stuff to, you know, paint maps and all that stuff. But, you know, last week I talked a little bit about, or no, actually talked a lot about, you know, noises and things like that. So this is absolutely a perfect place for a noise, because that's what's going on here. You know, like for the most part, it's just, you know, like some of this is where, you know, some of these have scratched against each other or something like that. So they have these kind of things. But, you know, if you go back here, and it also depends, you know, on how sort of in your face this object would be, right? If you were going to be close up on it, like traveling through the treads or something like that, obviously you're going to want to paint something that's very, very, very realistic. But if you look at this right here, you know, like I said, this is just noise. It's just, you know, there's just not that much interesting going on here. So it's like I said, it's a perfect place for throwing a noise in there. So if I take it and I grabbed, Arnold's, I went in the Arnold area, and I'm using their noise because just for ease of use. Okay, you'll see what I get here is just this kind of you know, lightly noisy pattern, and you just got to kind of mess with it. So I just scaled it up, meaning like, so scaling up is, let's see if I can get it to interactively do it. There it goes. Okay, so you see as I move that number up and down, it's basically just, you know, if you thought of it as almost limitless, what I'm doing is almost zooming out on it, right? So the higher this number, the more you zoom sort of away from the surface, right? So I'll just say 12, 12, and 12 for this thing, and then let's see, luminosity I think will increase sort of the detail or not. Distortion kind of like messes it up, which is kind of nice if you look at sort of the way it's kind of like just kind of monkeying around here. It almost looks like maybe I'll come down to 2 octaves. Will that will definitely make it more detailed. So if I bump up, yeah, see how I'll just go back to 2. So you see how I'm getting this kind of like just monkey, this odd pattern. So, okay, so to use this properly, all you need to do is really, if you come back here and you say, okay, I'm going to plug this into my roughness, right? So my roughness is at, right now, I want to be somewhere, I want to just play around in the 0.38, or we'll call it 0.4 to save time. Okay, so if I come back here and look at this is creating, now keep in mind that remember that we talked last week that color in each channel can be seen as from 0 to 1. 0 being black, 1 being white, right? So that means any of these values coming out of this guy, where it's black or really dark, it's gonna give that input 0, and where it's white, it's gonna give it 1, right? So we obviously don't want to, like, if we wired this straight in here, and we'll do that. So keep in mind, remember that the roughness is just one value, so we only need one of the greens. You see this here? We don't want a color out of it. We just want one of the channels out of there. Okay, which may seem a little odd, but makes sense. So so what we're looking for is we come over here. We come back to our shader, or sorry, our rubber shader. So we're looking for roughness, right? And usually these are named properly. Believe it or not, sometimes they're not, which is a huge bummer. So it's called specular roughness on this side because it's, well, it's under specular, so we're under roughness. So all we got to do to bolt these two together is go like that. Now you see what we get. We get something that's too shiny in areas and not shiny enough in other areas. Okay, so you can see it right there reflecting and everything. So it's cool. It's giving it, giving that surface something different. But it's too much. So all you have to do to change that, obviously, is we want to decrease our value. So if you think of the colors here, and I'm going to go back into, no, this is right. So if I turn off my saturation, let me get this up here so you don't have to look down there. Okay, so I have no saturation. You don't worry about the hue. So if I type in 0.4 here, okay, I won't get what I thought I'll get. Well, that's weird.
Why did it reset your specular roughness back down to 0 and you connect to the nodes together? Is it supposed to do that?
Yeah, because it's now mapped. I mean, over here, if I go, yeah, that's because it turns out when it's wired up to something else, you get this, and you get you get the yellow box. Okay, so that's telling you that something's mapped in there, and that's this guy. So. Exactly, yeah. So the weird thing is, hold on, rendering space, display space. There we go. So 0.4 matches closer to what I had in there. I changed my for some reason, display space versus rendering space is different. If I type in 0.4, I get a really weird, really white thing. So I don't want that. So I'm going to turn that down. Usually you just eyeball this because you saw what you had before. And then the easiest way to do it, or way to set it up, is just to put both numbers in the same thing. So, whoops. Both numbers in the, so these are the two colors that it's going to combine to make this noise. Okay, color 1 and color 2, that's the two right here. So, Well, that's not what I wanted. Hold on. So these aren't matching, so that's kind of a bummer. Well, in theory, you should be able to put those numbers in there. Well, okay, so anyways, I eyeballed this. In the easiest way to think of it, I guess now is about 4/10 of the way across the way. So halfway is about here, so I'm going to just come down to there. So this is about where I was at before. Pretty shiny, but or somewhat shiny, but not at all, not completely shiny, right? So now all I got to do is change one of these values, and I'll start getting something different. So I'm going to zoom in. Oops. I'm going to zoom in to the surface here. There we go. So I can get a good look at the surface. So if I bring one of these down, I'm going to get shinier because we'll be heading towards black. There we go. Now you start to see the surface sort of get a little messed up, a little mucky. So there it is when the colors are about the same. Here it is when I bring them down. See, I've got just something going on here, a little something going on out here. And if I zoom out, please zoom out. Computer. Okay, great. There it goes. There, so now I'm getting, yeah, so now I'm getting something, like I said, with a little more variance, a little more, I'll rotate it around a little bit. There we go. So yeah, you see these things right here. So if I come back over to my color, I'm gonna actually pause, just come over to my noise. And one thing I would do with it is maybe make it a little more contrasty. You see here, like, you got an area that's really not shiny, and you got some other areas that are a lot more shiny. So if we come back to the color, or just unwire that, there we go. So you see how it's kind of, let's see. The nice thing is when you unhook it and just look at the surface, it updates really quickly because it's not trying to do a render on the whole ball there. So let's see here. Good Lord, it's P.
What does the P stand for?
I have no idea, to be honest with you. So all the, these formulas for making all these noise and things like that, same thing. They've been around for years and years and years, and it's just sort of, I hate to say it, it's just something you just kind of, you figure out which ones you like or which ones do what, and you just keep, you know what I mean? Like, no one ever teaches it. Just, I mean, somebody does, computer scientists teach it, but like, you just kind of like learn, like, octaves makes it denser. Like if I go back here, you see how it's kind of softer, whereas if I crank it up to 5, it's, it's much more, there's much more detail in there. It's just how many times the algorithm or whatever is run, and I'm sorry I can't explain it to you. I just don't know, to be totally honest with you. Right. It's something about the math and how these things are made. It's like if you go out and you look at, like, this is how it's made, like, whatever this means, and sometimes you can actually even find these things in here, wavelengths versus amplitudes versus all this stuff. It's just like, here's your P, like, it's got something, that's it, but I have no idea what it means, so sorry. I wish I did. Okay, so anyway, so what I was looking for was trying to get more contrast out of this thing. So actually I'm going to switch the colors. I'm going to bounce this up. So my lighter gray is taking the place of my darker gray. So I will get something a little noisier. Okay, so I'm going to plug that back in here. Specular Roughness. And like I said, I mean, it's subtle, but I think you can see what's going on here. I have areas that's shinier, areas that are less shiny, and it just creates something that's a little closer. So I'm going to unplug it. Oops. Go back to my 0.4. See how perfect that is? Too perfect, you know? It's not quite there. Whereas you take one of these guys and you set it up real quickly and you get, oops, whoa. You get something that's like this, a little more, you know, a little nicer. Okay, so anyway, so like I said, this is rubber is a perfect example of why, you know, of when you want to do that kind of plug-in, and once again, it's like, you know, why you want to plug a noise or whatever into at least one of those channels for that. You also got the, you know, these lines are actually like sort of when they make this, it's, you know, so these are scratched in there, so, you know, there's ways to deal with that we'll talk about. So here you could actually, you know, if you look at this, if you're trying to make this, you know, you can vary up the color. There's actually sort of some browns and blues going on. Most of this is probably from Reflection, and that's just an old tire. So, you know, this one's more about dust and stuff like that that's on it. So anyway, so now we're sort of moving our way towards objects that are more that are shinier, that are using more of the specular part of your shader, right? So then from there, we move on to your plastics. Okay, so plastics is where things start to veer off. And
I have a quick question. I'm sorry.
Sure, no problem.
My undo cue is turned off.
Okay.
How do I turn it back on?
Yeah, you go into your if you go into your preferences, so window, settings and preferences, there's literally a thing here somewhere that literally just says undo cue, and you can't search for it, which is hilarious. Did you find it?
Yep. Under the times line.
You were right.
It's like almost.
Where'd you find it? Files and
It's almost
project?
on the bottom, you see undo. So
Right.
Xgen and then on top. And
Yeah, there it is. Ah, yeah, that's it.
Awesome.
And you can choose how big you want your cue to be and all that stuff.
Okay, thanks.
Yep.
Andy, I had a question.
Sure.
So there's a drop down in your noise node that's a coordinate space.
Yeah.
Is that what you're going to use to edit? Like if I wanted to keep the clarity of the texture, if I try to resize the actual like model, like if I make it bigger and I don't want those textures to stretch out. And look all
Yes. Yeah. Yep. Precisely. Yeah. If you say world, that the object will actually sort of travel through the you know, it's sort of like, if you scale up your object, will it stay, what you just said basically, will it stay with it, or will it not stay with it, or what's used as the thing that to reference?
Right.
Yeah.
So like you get two different size tires, like the clarity of like the roughness isn't going to be different. But
No.
They're going to be the same, right? So what
No.
is like a world to keep those that way, or?
Yes. Yeah. Like if you wanted to set it up to be sort of to stay the same, depending no matter what the object is, you would say world. You would stay with you would go with world. So you could say, like, because the scaling is arbitrary here. You know, I just put these numbers in because it started to look fine to me, and there you go. You know, so if that wasn't working out for your other object, you would just scale it down. But you're totally right. You want to make one that you can put on. You know, you want to make something that's like 1 meter or 1 whatever inch of this stuff equals an inch of the same stuff in another object. Does that make sense?
So the scale is so when I have it selected on world, I pretty much have to make sure my numbers in this settings are like actual measurements.
No. They would be, because it's all BS. If it looks good to you on this object, it's going to look good. If it looks good on a bike tire, it's going to look good on like a bulldozer tire. If it's in world, because you haven't scaled those objects. Do you know what I mean? Yeah. And then there's other modes, and we'll get, you know, I don't know what that one is, but UV is the last one, and that's where they're literally, it's wrapped around the object, and, you know, we'll get to all that stuff. But that's basically the concept that you're talking about there. I don't know why that doesn't look right anymore. Okay, so if we move down the line, we're going to talk about plastic a bit, and so this is where we start to talk about, and it kind of veers off from plastic, because so much plastic is somewhat translucent. Okay, but first we're going to just talk about plastic that's not very translucent. You know, your blacks, you know, your like black plastic, deep blue plastics. You know, usually the lighter the color, the more you're going to possibly see through it. Unless it's like Apple, you know, like if you think of an Apple connector or something like that, that plastic is barely translucent. So anyway, so that's what we're going to veer off in that direction next, right? So we're all, like I said before, all we're talking about is very solid objects right now, the objects that aren't transparent, aren't translucent, or enough that you could ignore it. Okay, the thing to remember about translucence is that it's one of those things that's very expensive in your renderer, right? So anytime you can get away with not using it, you want to, because translucent objects, like I was kind of drawing back here on this dealie, is, you know, and I guess maybe I'm jumping ahead a little bit here, but literally, you know, this is a light ray. You know, translucence is light that bounces around inside of an object, right, and illuminates inside, right? You know, some bounces off, and that's your shine that we've been talking about. Some bounces around inside. Okay, like I said, those calculations are really expensive. It's great that they can be done, but you're going to pay for it. So, you know, it's something you want to use sparingly if you can. So that's why a lot of plastics, you'll err on the side of not a lot of it. So, you know, Lego pieces here, if you look at these Lego pieces, this is a good example of plastic that's slightly translucent, but enough that you could probably almost ignore it. Okay, so if you look here, you look at the red, and like I said, you know, some of these other ones that are less pigmented, your blues and your blacks are often like barely translucent, whereas like your yellows and things like that, okay, it isn't. So if you look here, you know, you can see, like, if you just look, and you can just sort of see how the blue looks just so much more solid than this red, okay? You see this down here, you see how like light, and, you know, I mean, this is compressed and everything, but you see how like light, it looks like it's semi-transparent, just the lightest amount, okay? You know, whereas this, it just looks more like paint, like, you know how paint is very, you know, like liquid paint is very, it's not translucent, you know? That's what we're talking about here, okay? And so with plastic, I got some other ones here. So these eggs, so these are starting to get there. Like I said, you know, you can see the light kind of going through these guys. They're semi-transparent, semi-translucent, okay? This guy, a little bit, see how it turns orange, the light. So the light is coming in here, hitting the, let me zoom up this guy. I don't know why everything's so low res. Okay. You know, light is obviously hitting here in the plastic and distributing in. Oh, it's actually got a little red stripe in there, but you can also tell it looks like candy. You know, it looks like, you know, it doesn't look as solid as these blue areas. The green is slightly translucent. The red is a little bit. Okay. Long story short is, you know, these are, you know, if you want this to look really real, this is where you start to try and turn this on a little bit and deal with it. Okay. So this is a complete range, you know. This you can actually start to see through, you know. You can see the orange guy behind it, but it's, you know, not entirely. Whereas this green is very solid. There's a little bit of translucency in all these, but you know, for the most part, they're reasonably. These guys are reasonably solid, and these guys aren't. You know, and plastic is another one of those ones that's, you know, it's all over the place, you know, like from a sheen standpoint, meaning like plastic can be, you know, polished to a, you know, crazy shine like Legos, or really diffuse like these guys. You know, there's a little bit going on here, there's a little bit going on there. This is a good example of kind of a medium plastic. Okay, it's, you know, it's you'd call it shiny, but it's not really that shiny. So this is kind of a good place to start. So we'll just kind of go for that one. Okay, so I'm gonna call this new one my blue plastic. And maybe we'll sort of, maybe I'll just move over there. So I'm gonna get a new tab by clicking new tab. I'm gonna get a new shader. Standard surface, okay. gonna dump it on there. Okay. Ow, shit. And I'm gonna name them because I should be naming the plastic. Okay. I'm gonna turn down my base color just so that I'm not sort of confusing the issue here. Now, keep in mind, you know, plastic. You know, we also talked about index of refraction before. Index of damn it. Here we go again. Refraction and reflection, okay? And plastic is where that really starts to show up. And some of these other ones, you can kind of ignore it a little bit, but plastic, you know, I think largely sort of lives and dies with how successful the index of refraction is, okay? And what that means, remember, is as an object, as the surface of an object is facing farther away from you, the more reflective it appears, okay? Now, you can see it even here. You see how on this edge, as this is rounded off, you see how shiny it is here, whereas where it's facing you, even though there's light and things going on here, it's very dimmed back, okay? This is your index of reflection doing its thing, okay? The Fernell effect that I've talked about, and that's what that is, right? Okay, that's why it's really deep blue here and less deep blue here, because we're seeing reflection off of the ground, and then it's very light at the edges. So plastic is like a really good one that has that this really shows up on, okay? So what I'm going to do here is like I said, we turned off our base color, and I'm going to turn up my roughness, but just a bit. Because it's actually, you know, if you look at this, it's, you know, it's reflecting reasonably. Like you can tell that these are light sources. You know, some of these light, like they have a little set like we made the other day where it's got a, you know, so you can actually see the end of the table here. That's what this is. Just like we have in this scene here. I made that, you know, that's what you're seeing. You're seeing the end of this white table, okay? Goes out here, this is all black, this is probably the room, and this is the lights they use to light this thing with coming at you. So, you know, since I can see, you know, some lines here, obviously this is reasonably reflective. You know, if this was just a blob, if it was, you know, blowing that out to just kind of a blob, you know, meaning if the surface was rough, that reflection would not be so easy to see, right? Or you know what I mean, make out. Okay, you can tell what's going on there, right? So I'm just going to bring this up just a little bit so I can still see, you know, here I see my light sources, okay? But if I go back here, I actually pulled up, well, what I was saying the last time we played with this, I like plastics with an index of refraction somewhere in the like 1.35 area. So you see what I'm saying is that notice how there's still a tiny bit of reflection coming at you. The reflection on the outside is reasonably, you know, there's a decent amount of reflection as it goes away from you. Okay, I'll tell you what, let me turn this down a bit. So see, we still have some reflection, but just barely. But we have a decent amount as the surface turns away from you. Okay, does that make sense to everybody? Does everybody understand how that works? What that means? I put a video online about that. There were some good examples of how that worked in real life. If you saw that, you know, it was basically like a piece of glass, and you know, as it turned away from you, it almost became a mirror, but as you were looking at it, you could almost not see anything. And it's just about how reflective something is, okay? And it's really got to do with what I was talking about here with micro, you know, micro abrasions or micro surface stuff. Okay, like I said, there's nothing ever been created that's perfectly, that on a surface is perfectly flat. Everything is made up of teeny tiny facets. You know, like I read something once that, like, you know, the mirrors they make for Hubble, you know, for space telescopes and stuff are only 90% reflective. You know, they're, you know, you think of them as absolutely perfect because they have to be, but they're not. It's not possible, right? So that's kind of the point of Fernell reflection, is that, you know, everything has these little imperfections which create that, but as a surface sort of, you know, turns away from you, or looks like it turns away from you, it is sort of like adding up all that reflection, and reflection that may not seem like much here, you know, is because this is sort of like, you know, if you took a sample and said how much reflection is coming up here, there's not much there. But as this squishes away from you and becomes just this little, you know, a little sample, all that is added up to become a whole lot more reflection. Okay, and that's, like I said, that's the point of that kind of reflection. Okay, so, you know, if I bring this number up higher, you see I get into, you know, it starts to look chromy, and it doesn't look like plastic, you know. So, you know, if you bring this, even if you bring it too far down, you know, it doesn't look like it's got any shine to it. So like I said, I mean, I've always found somewhere in the 1.3s and 1.4s to be a really nice number for that kind of stuff. So now all I have to do is kind of bring up my roughness for that plastic, and then I'm going to do that blue. Oops, blue. Okay. So I'm just dealing with this really bright blue here for now. Then I would just mix it in like so. Maybe a little brighter. And depending on the, you know, lighting scenario, you know, it's going to look different in different lighting scenarios. That's why you should try these out. And one thing I did talk about previously too that is really important is, you know, when you're laying these things out, it's really important to sort of trust. That's what's so nice about Maya, is the ability to try out these different lighting scenarios, because other softwares don't have this, right? And they're really valuable in that, like, if it looks good in inside, you know, interior, exterior, like, you know, you've got a good surface. And if you're having any problems in your scene, it's probably your lighting. You don't want to adjust your material for your lighting scenario. You want to adjust your lighting for your material. For your material, right? If you make something and it looks good in here, but it's not looking good in your scene, something's wrong with either your object or your lighting scenario, and that's where you need to look. Because once you start messing with one, you're going to have to mess with the others, because, like I said, you're adapting to the wrong thing. You want to adapt your light to your surface, not vice versa, because this editor here, like I said, if you kick this through all these scenarios and it looks like what you're thinking of, or what the surface should be, if it's a real surface, like I said, then it's your lighting scenario. So mess with that first. Okay. So this is you know, a fairly decent, you know, model of that blue. It's not too shiny, but shiny enough. I need to kick it down just a little bit. It's got a decent index of reflection or refraction, reflection in this instance. Okay, where we see a little bit of shine coming at us, but a lot more as the surface turns away from us, and that's pretty decent. So, you know, the nice thing here is I could copy this out, or I could duplicate this out, and I could make my red out of it and stuff like that. If I like my surface setup, then that's great. Then I'm good to go. Okay. So this is one we'll circle back around to when we talk about translucence. So I'm just going to continue down the line to these other surfaces real quick. Metal is another one, just like plastic, in that you know, obviously it's got a whole range of surfaces, or treatments, you could call it. Okay, so if I started here, and I got some good examples. So that's all my plastics. These are little pellets that they actually make plastic stuff out of. Those are those bead thingies. Okay, so yeah, like I said, you know, metal has everything from, you know, perfectly shined chrome to, you know, raw metals. This is aluminum with, like, it has kind of a casty kind of finish, where you can see it's actually got kind of it's got a surface as well as a shine. That's steel, looks like. So this is like, you know, brushed steel, or sort of roughed up steel. Same thing, kind of roughed up steel. Stamped metal, steel. And maybe this is probably a decent one to play with. So this is an interesting one in that when we talk about chrome, you know, so as we get away from, at the start, the things that were important were the base, somewhat were the base colors that we're using, and the specular or the reflection were sort of less, less contributors to the contributing a lot less to the overall surface. But as we go to the right here, more and more it's getting important, right? And when we get to chrome, obviously, like, that's all that's important, because that's pretty much all you're seeing, right? And that's kind of the point, in this, in that as we dig through, it's like, this, we're at the middle here with this plastic, right? And then, like, now the blue is important, and the reflection is getting sort of less important, because is the color right? Is the light going through the object right? And the shine is kind of an afterthought in a way. I mean, it's still there and it's important, but it's becoming less important. Or it's about in the middle, I guess you could say, right? So these metals are right in the middle there, and that there's still surface here, but a whole lot of it's being done through reflection, right? As you can see, this is pure reflection, and it's real reflection. So in this instance, we have surfaces I should make like 10 of these. So if you think of the metal, so we have, things that are hitting and bouncing off, absorbing some color and putting it back at you. And we have light that's purely reflected, right? Remember, we talked about how, light that comes off a surface is just what's not absorbed by the surface, like a black object, or sorry, a yellow object is absorbing all these other colors except yellow, and that's why it's bounced out at you. That's why you get, you get a light ray that comes in, and then it sucks up all these things, but gives you yellow, right? And the reflection is just literally bounced light at you. Okay, that's a little. I'm sure that's a little confusing, but that's exactly what's happening. So the light is bounced at you so that you're seeing like a mirror, or the light that hits a surface and comes at you that's not absorbed by the surface is the color of the surface. Okay? So when we get to metal, this kind of metal, that's what we're seeing. So we actually mix in. So in this instance, we'll have both a decent amount of base surface and we'll have a decent amount of specular. Okay, so like I said, if I'm worrying about these guys right here, you can see a decent amount of gray, just kind of gray, shiny, but very harsh, harsh reflections added in there, right? So what I'm going to do is just come here, and so I'm going to bring up my index of reflection so that I get a lot more of the reflection. I'm going to rough it up a bit, maybe 0.25 we'll say. See, what do we get? There we go. So if we look here, you've got these kind of, so I've got a good light source here that's fuzzing out, somewhat like this is doing. This is probably a pretty harsh light source up here that we're seeing reflected there. Maybe could use just even a little bit more. We'll say 0.3, and we'll bring up the index of reflection even more, which will give us more shine. Maybe I'll come back a little bit, say 0.27. See what I mean? Like this roughness, the roughness setting is really important, because it sort of makes all the changes, or makes all the difference. And a little bit of change from 0.25 to 0.3 makes a lot of difference, right? So now I'm going to turn my weight down for my reflection, go back to black. Now I'm going to start turning up the base color, right? So the base I'm going to call just essentially gray. Any color that you see here is going to be reflected in the scene or something. It's possibly about color correction of this image, so I'm just going to leave it. I'm going to put in a gray here, like so. I'm going to turn that up. I'm going to turn the metalness, so this is literally metalness. It's almost like it's treating the base layer as an undercoat of the metal. Like I was telling you back here that when I drew this bad demo here, is that, like I said, there's reflected light and then there's reflected color, right? So it's treating the reflected color like a essentially like the shininess down here, but for the main layer. That's why it literally just looks more metal-like. So you see how it's, instead of by default, it's kind of like this diffused out. If I turn it down, in fact, very diffused, I'll get like very metal-y out of it if I turn it back up. So it's, like I said, it's like another layer essentially. Okay, so now if I mixed my specular back in to about here, and wait, and wait. Now I'm starting to get something that's, and I'm going to turn them both up a little more. So now I'm getting decent reflections, but I'm also getting kind of a good base layer. Okay, I'm going to go back into the interior shot, or interior lighting scenario. Yeah, so we're getting there. So it's maybe could even be a little brighter at the base, like so. So this is like, this is like a galvanized stamped steel. So all these other little details you'd have to, map in there some different way. But as a base, this would be another decent scenario for a noise, in the reflection, just to kind of muck this up a little bit. I mean, it's pretty clean, but you can kind of see some variance in there. It's just how much time you would want to devote to a piece like this. Let's see. So, I mean, in the reflection, it's pretty clean, so, you might not have to mess with it too much. But, these kind of scratches, if you could use a different way to make these areas a little shinier where it's been stamped down or whatever. But as a base, we're kind of getting there. We're getting decent, blown out reflections here from really bright light sources, but we're getting some like sort of a basic color that's in there, because once again, this surface it has a surface, but it also has a reflection. It's not all reflection. It's mostly reflection. Okay. So yeah, you could just sort of tweak with this one. But I'm gonna, you know what? If anything, I might turn the roughness down just a tad again. See what just 0.2 there, or 0.02 makes a huge difference in your roughness. Like, roughness is definitely the one to get to know in that area, because it makes all the difference in the world. I mean, if I just go to 0.26, I'll probably get something a lot different. Oops, 0.26. Okay, so yeah, so that's anyways, so that's a surface, made of both an important base color and an important reflection color. Okay, and that would, this scenario would make sense for pretty much all these. You can see, like, this is very rough, so the base surface would stay pretty rough, but there is a decent amount of reflection going on here that wouldn't get mixed in maybe as much. This is a great one in that it's got a lot of, there's color here, and there's a really messed up shine layer with some really shiny parts, and like where it's really scratched, it's really shiny. Same thing here, but you can see it has a surface. Okay, whereas chrome, aluminum's a really good one, and it's actually really hard to get a decent aluminum, because you see how it's kind of like, aluminum's kind of got like a layer of almost light, almost gray white when it's raw, but it also has like a sheen in there. It's so subtle that it's a really hard one to actually make a decent one out of. And then this is stainless steel, that's almost like the other one, just maybe a little shinier on that top layer. Oh yeah, and then this is a good one. This is kind of where we were at too. You can kind of see that there's, at no point is it black. Maybe in through here where there's absolutely nothing to reflect, but it has diffuse reflections, but it also is just overall, if you sort of squint your eyes, it's kind of gray, and that means it's not a chrome. It's not perfectly shiny. Okay. So that's how you mix those things. And once again, the beauty is like, once you do this and you get some, it's really important to save your presets and hold on to them, because once you sort of figure this out and you like this, it can be a base for, it's a good starting point for, any of these. So any of these, the plastic, the rubber, and all these guys, you could pull all those out and go, okay, I need a blue one, I need a black one, I need a whatever, So you get this going, and you've got a base to work with every time. Oh shit. Okay. Okay, cool. So then on the high end here, obviously, is your chrome, okay? And, you know, the only thing, we don't need to say too much about chrome, except don't turn it all the way up. Like I said, I mean, you see it all the time, and it pisses me off, to be honest with you, because it doesn't look right, and you, like I said, you see it everywhere. People create chrome by going standard surface. Okay. Oh, wait, what did I make? Oh, that's a hair. Sorry. They get a standard surface. They get a standard surface. There it goes. They get a standard surface. They put it to black. God damn it, I did it again. Sorry. They crank their index of refraction up to 10. They turn this down and they go, look, it looks like chrome to me, and then they're done with it, you know. But once again, there are no perfectly reflective surfaces, period, in the world, ever. It's not a thing, right? So when you're doing this, go conservative, because it's also something you can always push in post. You know, you can always go in and you can add a little bit more. If something's perfectly reflective and it's blowing out, and it's, you know, meaning all your reflections are blowing out to white, there's nowhere to go. You can't get any of that back. So it's like, just back off on the at the very least on the weight of it. So like, for instance, so I'm gonna turn my weight up just a tiny bit on the surface, because once again, I mean, it's still metal under there. So if you say I'm gonna use a very dark gray, I'm gonna just turn it up just a tiny amount. I'm going to turn that metalness way up. So this is for my base layer, right? Okay. And then I'm going to put a whole lot of specular reflection in. And I'm going to turn it down, but I'm going to leave it on just a tiny bit, maybe 0.05, let's say. Because same thing, you know, like I said, this is, you know, even though this looks perfectly shiny, it's not perfectly shiny, it's very shiny. And that's a big difference, or there is a big difference between those two things. So we'll go maybe down to 0.02, right? Index of refraction reflection will turn up a bit, maybe to 4, we'll go 5. Okay, so like I said, this is very shiny, but there's somewhere to go with this. I can bump this up, and if you go out to other some of the other lighting scenarios, it should look pretty good. Maybe a little higher still. So by cranking this way up, 6. So you know how, so you see here, I'm at 0.9 something. So like I said, that's leaving a little something there behind, because I'll go to 8. There we go. Maybe bring my weight and my base up a little bit. Okay, so now we're getting there. Like I said, the big takeaway here is just don't crank it all the way up to you know, a billion, because it doesn't work. It doesn't look right, and it doesn't work. So I'm gonna keep mixing my surface in here a little bit more, and I have a lot of metalness going on. We'll just go to 10. So yeah, so at 0.96, it's mostly shiny, but not 100% shiny, but very chrome and close enough. Yeah. Probably, yeah, my monitor's a little washed out. Okay. So yeah, to make any of your colors that come off of this, like gold and things like that, all you have to do is you know, color your reflections. It's pretty simple, you know. So we've got this. So yeah, to go to gold, you know, it's you know, you're just controlling what you want to reflect. So if I go back over here, eventually, and I change the color of the reflection, like so. Okay, I start to get gold, and I'll put a little color in the base. Ooh, too much. The tough thing with gold too is that it's really easy to go too orange and it's really easy to go too green. So it's a weird color to get in there. You see how it looks kind of green, but it's like if I tweak the hue a little too far, like I said, it goes orange really fast. That's not too bad. Okay. Jeez. Man. Yeah, see now it goes too orange. Like I said. But yeah, so all you're doing is controlling your reflection. So the whole, the bulk of this is done through the reflection. The base has a whole lot less to do with it because we've moved from surfaces that are mostly done through, really the color that's underneath, like a paper, if it should be a color, you put a texture underneath it or whatever. Same with your cloth, the cloth is just what's the color and what's the makeup of that, and then we got your specular shine that starts to get messed up in your rubber. Then the plastics, you start to get more shine, and the shine starts to become important. And metal becomes a lot more important, and then your chrome, it's all that's really there. It's all about shine. So that's sort of, like I said, that kind of the spectrum between those two and how they're sort of mixed in there. Okay. Now, like I said, the next area we want to talk about is when you go in this other direction. We've talked about objects that for the most part are solid and are bouncing a whole lot of, either bouncing through reflection or through light, reflected color at you. Okay, so now we're going to start. The next step is talking about objects that are either transparent or translucent, and they're kind of functions of the same thing, right? So glass is what you would call, obviously transparent, right? And that only means really for the most part, right? In that light is coming in and it's getting refracted or bent, and that's why things, look weird in water or through a glass or, whatever. They get that, things get, wiggy or whatever, that's the index of refraction. When light comes in, and, every substance has a different index of refraction, right? Water, quartz, glass, all that stuff, right? And I actually have a really annoying spoilers. Okay, so these are index of refractions for way too many things because they're not that different and it's not that important to be that close, right? So acetone, so somehow they figured all these things out. They're like a lot of the important ones are to remember, like ice and water, normal glass, which you'll find, they call it a few, they have albite glass, crown glass, flint glass, blah, 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 right? You see, they all kind of play, well, they kind of vary. So 1.5, and then, your ice is like 1.3, which is interesting because water is, like a little higher. It's interesting. So water, the index of refraction of water changes as it heats up or cools down, which is, I guess, somewhat interesting. But anyway, so the point is that that's what we're talking about here. Okay, so we're talking about objects that are reasonably transparent and what they're reflecting. Okay, so these ones are a bit easier to figure out than the ones that are translucent. Okay, and to do that, so Maya and Arnold, and you'll find this called different things in different programs, calls it transmission. Okay, transmission in Maya just means the transmission of light through the object, right? It means transparency, and it also means translucence, okay? And that's this tab that we haven't talked about yet, okay? So if I go and I get another surface, and let's see what we're gonna try and make here. So I'm gonna try and make tell you what, I'm gonna actually go back to my plastic because we talked about plastics that you can see through. Sorry, gotta find my plastic area. Okay. Yeah, so that's decent. Let's go back to this one. So this is where we're at. So, we largely talked about plastic that was mostly not translucent. But now well, no. I'm jumping ahead of myself here. Sorry, hold on. I am jumping ahead of myself here. So, sorry, we're going to actually talk about objects that are, that I'm going to jump to the other end because it's a different thing. So, sorry about that. So, okay, I'm going to jump back to the simpler part of this, right? And that, like I was saying, that's like glass, right? So in glass and things like that, and glass and water and stuff like that, light rays are largely, they go through the object and are just bent and then presented out back to you, right? So that's the transmission, largely what the transmission tab is doing, right? So if I'm going to make a new glass shader here, I'm going to pull out my regular shader here, just call it glass. Oops. Okay. So the beauty about these is that, the same way that objects that are shiny or really shiny are, mainly told by their reflection, obviously, glass ones are told through their refraction. You don't have to worry so much about what's going on in the surface because lots of times there's barely anything going on in the surface, right? So to do that, let me come back over here. Geez, there we go. Okay, so we come down to transmission, and like I said, by default, if I bump this up, your object is going to go, when rendered, come on, hold on. Why am I not getting, oh, there we go. What the hell's going on here? Hold on, sorry, I'm having a little problem here. Surface, boom. Huh. She won't render. Come on. Let's go. Huh. Let me reopen Hypershade. Wow. Sorry, everybody. I don't know what's going on here.
Do you have the render screen up?
I do not. Let me make sure. Ooh, error at the bottom. Okay, no. There we go. Okay, transmission. There it goes. Okay, so like I said, if I bump up my transmission, transmission, you see I start to see through the object. Pretty simple. That means that, light is going through, and I'm seeing through to the other side. If I turn my roughness down, and you can do some scattering in this one too. And I'll show you. Okay, so with that all the way up, and this is another one of those scenarios where you don't want it completely all the way up because nothing's completely see-through. So maybe even 0.97 or something, just a really, really high number, just so that your surface still has a little bit of surface. So, because if I go into my glass examples out here, okay. There we go. You see what's going on. Obviously these things aren't, this is just, pane glass, whereas this is like a drinking glass. This is like a blue tinted glass with a little bit of blue in it and all that stuff. So okay. So, if I come back here and I'm going to turn down some, my other components, I'm going to turn down my base. I'm going to turn down my specular shine. Uh-oh. And I'm going to lose. There we go. So now all I'm looking at is how things are going to be refracted through here. And you can see it's like already fairly effective, you know, it already starts to look like glass. And you got lots of options down here. Now your index, so your index of refraction would go in here. So if this is, you know, if this is truly supposed to be a, you know, a normal glass that we're all kind of used to, we'll just call it one of the glasses in here in a 1.5 area. So all I got to do is put that, oh, it already is that, 1.5. So that's going to be bending light the way that this is bending light, you know. So, you know, you see, that's what's going on here. This, you know, you're seeing the background, you're actually seeing like part of the room sort of like bent in through the glass, and same thing here, okay? So now we're seeing through to whatever else was in this HDR, right? So it's reasonably, you know, it's, I mean, part of this, you know, in this instance is partially gut. You just kind of look at it and say, well, that's what I'm going for. So now to tint those things, you know, like if I was going to do this kind of sheet glass that, I guess this is kind of like glass they make tabletops out of, you know, you can see there's it's actually not super transparent, right? So all you have to do is you just tint it here, you know, so you could go sample that color. And
How did you make it transparent?
transmission? Transmission is synonymous with transparent, really. It's meaning, you know, transmission through the object, right? So, like I said, a little bit goes a long way here. You know, like to make that green, all I got to do is kick a little bit of that in there. It's like I said, it's funny how little you need to make a decent glass there. Okay. So, so some of the other things that you can do in here is you can scatter it around a little bit. The way, like, there's two types of scattering in the Arnold shader. Remember what I was talking about over here? Here with this guy is that, you know, like I said, the light that's scattering around in here, like when we come back to here, this is light that's just going pew pew through it. You know, then we talk about surfaces that start to, like, you know, diffuse it in through the surface, and that's things like this milk. That's what I was trying to getting into these guys. You know, this orange juice. You see this? Like, you can obviously see that it's like light is coming through a lot of it, but not, you know, a ton of it. So you see this volume, right? That's light that's getting scattered around inside of it. You know, and actually is happening in the orange and in the orange juice. Milk is another really good one. You see how it's like, you know, it's that translucency. Okay. Well, you can do a little bit of that with that shader by doing by sort of scatter, by, you know, turning up your scattering and your depth. All right. So that scatters around the way it becomes a little more, a little less clear, I guess you could kind of say. Okay. It doesn't go a long way. That's why they have subsurface, and that's what we're going to get to next. So anyways, I'm gonna keep that down for this because I want that glass. Oops, I shouldn't have screwed with that because that messes things up. Okay. There we go. Depth, if you leave it at 0, it just goes right. We're not gonna mess with depth. Okay. So this is I made the glass that I was talking about. That's kind of got a slight green to it. It's like that plate, you know, plate glass with that slight stuff through it. Okay. So real quick before we get done here so transmission is pretty simple. You can tint it. You can mess with the index of refraction, which you can get here in this chart that's actually out there on the in today's class thingy. And it's also got a smaller one. This one is much more easy because, like I said, you know, you don't need to tweak these. So, you know, if you know water's about 1.33, glass is about 1.5, blah, blah, blah. It's close enough. You know what I mean? Like this is for like some anal retentive weirdo that really has to get it perfectly right. But, you know, whatever. So anyway, so to make any of those surfaces, you plug that into your index of reflection, refraction right here. You know, they go either way, and then just the transmission, depending on what it is. It's like if I start to bring this down, okay, I can still mix in I can mix in a surface if I want to. So now I've got kind of like a frosty glass, you know, where it still has a surface, especially if you roughen that up a bit. Okay, so I've got a lot of refraction, but not a ton. And I can bring in a specular reflection. And I'm going to rough that up just a tiny bit. Tell you what, I'm going to mix a bunch more in there. So if I take these down, if you think of like a frosty glass, you know, like that, like literally, you know, purposely frosted glass, all I got to do is take a level of reflection and then mix back in my diffuse, or I'm sorry, my transmission, and now I've got that like frosty glass kind of thing going on. So that's the great thing about the weights is, like I said, you can turn these down and you can turn, you know, without blowing all your settings, you can just sort of turn them off and then turn them back on to mix it together. So you can isolate all the layers that you're trying to get together. But Violet, do you have your hand up? Yeah, oh, sorry. What's up? I'm sorry, what's up?
How do you change the glass color?
The glass color is right there in the transmission color.
Oh, really?
Yeah, so like, yeah. And like I said, all you have to do is mix in a tiny amount and you get a whole lot out of it. So like, if I move it over to red,
Nice, got it.
I get kind of, there we go.
So if you're making a diamond
Mhm.
and you use the glass,
Yep.
the
Shit.
the glass shader
Uh-huh.
thingy, would it be able, because you know how a diamond has so many different edges,
Mm-hmm.
would it be able to layer those on top of each other?
Well, that would all 100% be like how you model the diamond. You would model all those facets and you would get that shine out of there, right? So like if you know, because that's how they cut a diamond with all those little, you know, bips, you know, like facets they call them, you know, that's what does all that refraction and shine and stuff like that. So if you model the diamond right and you made a surface that works, it would work perfectly.
Okay.
Does that make sense?
Yeah, because for this one, the index of refraction is a lot lower than in that chart. That chart, it was like 2 point something.
Yeah, diamond, let's see. Yeah, 2.4. I think the higher the number, the more it's going to bend light. Like if you go into, like air is almost 1, you see that? So like air barely bends light. That's what 1 means, meaning like the light rays stay straight as they go through air, but it's a little bit. That's why they always say like the moon looks bigger or something like that on the horizon and stuff like that, because there's just a little bit going on, whereas a diamond is very, very refractive. So that's why it's throwing light in all these directions, because the light that's coming in is getting thrown off in more directions than almost anything else on this list, really. Fabulite, which I've never heard of. What does?
Steel?
Steel does?
Yeah.
2.5, yeah. So steel kicks off in a different direction too.
What does scatter color do?
Scatter, the scatter anistrophy, that's that one that should be bunching up. It changes like it artificially changes the direction of either reflections or in this instance refraction. So it's for objects that are sort of brushed and things like that. So it changes the way that those operate in kind of an artificial way.
Yeah,
Does that make sense to you?
One above scatter anistrophy, the color of scatter.
The scatter,
What exactly does that impact?
that should, but I don't see it doing that. Ooh, boy, it blows that away. See, the thing with the scatter is that should be done in the subsurface, which we're about to talk about in just a second. In theory, it's supposed to be literally scattering the rays around, like we were talking about, you know, in this example with the, you know, underlayment, you know, stuff, right? But that's not what it's doing. So I'm not sure exactly why it's doing that. As soon as you turn it on, it stops refracting in the way that you expected it to. Oh well. let me come back around to that one because I'm not entirely sure. I don't use it for that. So this is a good way if you, depending on how you mix it in, to get some light into some surfaces, because it's not as expensive as Subsurface, which is what we're going to talk about next. So like if you had a leaf that you wanted it to be semi-transparent, like you could actually mix just a bit of transparency in here, or a transmission that's diffused out. So like if I change this color, all right, and I said I'm gonna put green in here. Hello, there it goes. But I'm gonna also put a surface on it because it's a leaf, you know, and it has more surface than not. So I'm not gonna color this, but whoa. So I'll say this is my way too bright leaf color. I'm going to mix a lot of that surface in, and you know, this is something you'd want to paint a map for, or something like that. See how I'm getting some light through the surface. Okay, so like I said, that's sort of because we have a roughness up here, it's sort of scattering that out underneath through the object. We can mix more of that in. Kind of looks like candy. Okay, so the final one, the final rollout that we're going to talk about today is the subsurface, and that's what I sort of, like I said, I circled around because I want to talk about more transparent objects, objects that are more transparent first, but before I talked about objects that are less transparent. So in between objects that are solid and objects that are very clear, you have objects that scatter light through them, okay? And, you know, milk being a good one, orange juice, like I said, being a good one, you know, a ton of things being a good one. And the way you can test that out, and I brought some what do you call it, some visual aids here today, is I got a little flashlight, and a great way to test this out is, you know, is just with a little flashlight like this. So this is like one of those little sponges, right? So you see here, this is an object that's obviously scattering light through it. It's not transparent, but you can still see what's going on through it, okay? You know, same with this foam, you know, you can see not a light gets through it, but see the blue, like it's even more blue as light goes into the object, okay? And then obviously the old standard is, you know, your human skin is like that, you know, your ears, you know, you can see light through your ears and through all of your skin to a different degree, you know. Whereas, and even this is corian, you know, the stuff they make, you know, countertops out of. It's a good one. You can see it lights up, you know, as light gets through it. But the light dies, you know, fairly quickly. Same with all these. So when you go to test this stuff out, you can see, like, you see how about an inch away from the object, or away from the light source, it's not really going through there anymore, okay? And the great thing about Subsurface is that you have control over that. You can say how deep do those light rays go through there, okay? Whereas you have like clay, you know, clay has not, you know, absolutely none in this instance. That waxy stuff does, but you know, and then this plastic doesn't, even when it's thin, almost no light goes through there. Blah 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 blah. Okay. But once again, the problem with this is that it's an expensive procedure rendering wise, but sometimes you need it and you just got to deal with it, and you deal with the rendering, you know, impact or whatever. But, and like I said, it's a minor miracle that we can do it at all, right? So skin, you know, skin is almost a completely different ball game in that, like, people go in and they actually deal with the you know, your skin is made up of a bunch of different layers, you know, like there's a fat layer, and then there's a top layer, and there's a dead layer, and then there you get down to, you know, so, you know, really high-end stuff, they actually deal with like trying to model these layers, because each of those layers have different translucency levels, right? Like your top layer you can see through quite a bit, the fat layer not as much. So depending on a person's face, like how much fat is collecting here and there in your cheeks or whatever, they model all that stuff. We're obviously not going to deal with all that stuff, but these sort of things, you know, these are the sort of things that people actually worry about, you know, and that's why you see some of this stuff that's really realistic, you know, because you see here, these are some experiments that somebody's doing with a render, you know, here's the skin without any translucence, and here it is with translucence, is what they're saying, right? So, you know, you're getting this stuff, you know, it's subtle, but here the face looks like it's made out of clay, and here it's getting a bit better, you know, you can see through the cheeks, you know, the ear, just like I just showed, you know, you can see all that stuff. This is the stuff that you can do with this, okay? And so the simplest way is just to sort of jump in, and I was gonna mess with that plastic. Maybe I'll mess with the plastic. So come back to the plastic, and if I would have named it properly, I would have been able to find it. There it is, plastic. So once it gets its act together, there we go. Okay, so to mess with this, I'm going to do the usual thing. I'm going to actually try and remember here, 0.96 or so. So I'm going to turn off my top layer. I'm going to turn off my reflection, and then I'm going to come down here to Subsurface. So Subsurface, it has a normal weight that you can put in here, just like any other layer. Okay, you're just mixing it in there, and then you have a color that you want to show through the object. Okay, and it can be anything you like. It can be something that doesn't even make sense if you'd like, or whatever. But you know, obviously with skin, you're going to want like a pink or whatever coming through the object. But with this plastic, I'm going to go back to some of the plastics that you can see through. Jeez. I did a lot of Googling here this afternoon. Okay, there we go. Yeah, it's not a good one. Let's see. I guess these Easter eggs are kind of a good, you can see, you know, these are fairly translucent. So, you know, most times you're going to take the same color and push it through there. So since I was doing a blue, I'm going to do a subsurface scatter color of just blue. Maybe, there we go, like so. So what you can control is, so the radius is what I just showed you with the flashlight, right? It's the radius of light, how far the light goes until it dies and stops traveling through the object, right? So things that are more translucent, it lights up more, like the orange juice, you know how bright it is all over the place. Whereas this plastic, you know, it goes a little ways, but then it kind of dies out, you know, because it's essentially how much do you want it to be translucent versus how much of it do you want to be like, you know, more like latex paint, you know, like latex paint being kind of a good example of, you know, something that's really not translucent at all. Okay, so that's what they're talking about there. What's this radius, right? And you know, sadly, it's kind of an arbitrary number, and it's just something you have to tweak. Okay, you can map it, so that means that an object that you want to have more light go through, you can, in places like like I said, human skin works like that, or any skin, I guess I should say. You can map that, so you can put different areas to have that kind of thing, or have more or less, and then you can scale that. Okay, and the scale for an object like that being the main thing here. So so as I play with this, so you'll see when it was up at 1, it looks like, you know, it's almost all it almost looks like it's just made out of like I don't know, gummy candy or something like that, and that might be fine. But as I tweak this down, you'll see it start to kind of become more and more solid, and more like or no, sorry, less solid, and no, more solid, I'm sorry, and sort of get more definition, right? So if I go to 0.2, okay, now you're starting to see, like, you know, things are going through here, but the light is dying as it goes through there, and you can kind of see this, you know, you can see the effect that it's having as you dial that down. And like I said, sadly to say, this one's a little arbitrary, and you just kind of got to tweak it. But this is the beauty of having an interactive render, is you're not doing this and then clicking render and waiting, and doing it and clicking render and waiting, and blah 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 blah. So by tweaking these two values down, I'm essentially shrinking that radius lower and lower and lower. I'm gonna turn it up a bit. So in this, so for what I'm trying to do here, I only want a little bit. There we go. That's not bad. So I actually want to turn it way, way down. And the good news is here is the less you use it and the lower the radius, the less expensive it is on the renderer. So you can feel free to use it. You know, it's things that are really translucent that it has to work hard on because it's literally shooting sort of computational rays through the object, and as soon as they die, it stops doing that work. So that's a little chunk. So I'm going to bring it up just a little bit more, and now I'm going to start mixing back in my original surfaces, right? So I'm going to mix in my specular that I liked. Okay. Now this is just another layer that it's essentially adding on top of there, so I didn't lose my subsurface stuff, okay? And then I can lay my color back in, so I have a solid layer. Keep going. And that's pretty good. Maybe a little more of the subsurface because it starts to get drowned out by that top layer. Maybe make it even a little lighter so we can really see it. Not blue enough. There we go. And there we go. That's pretty good. So maybe knock the blue down a bit. So you can see that, you know, that in through here, in through this area right here, you know, whereas we didn't have light going through there as much, we've got light that's getting mixed in there, and it has that kind of, you know, it has a bit of a translucent look because light is literally getting scattered through the object, you know. So if I turn it off, we should see a lot of difference here, or a reasonable, not a ton of difference. Well, some difference. Okay, so now this is with the translucence off. I turned the subsurface off. Yoo-hoo. Come on. There we go. So that's with it off. This is what it's contributing to the object. So there's a lot. It's adding a lot at this point. So if you go check it out in a couple of different scenarios. There we go. So this is with more harsh light coming from above. This will tell you a lot. Like I said, you can see a lot of light going through here. One way to check this out, if you've got an object that, you know, you're not sure how much is doing what, if you go in and you change your color to way off of the color that you actually want to use, you can see what it's contributing, and then just put it back to where it was. So now I mixed in this orange. So you can see a lot of this is being done with this orange and not that much with the blue, but you can see the way that it's traveling through the surface. So a lot of the work here is being done with this guy. So I'm going to keep turning it down, the radius down, sorry. So yeah, so like I said, the bummer is that radius is arbitrary, but once you figure it out, you know, once you get in the ballpark, it starts to make a lot more sense. A lot of this can be done with this. I don't barely need the top surface, just a reflection. Just put it back, and there you go. Ooh-wee. This thing is chugging. Okay.
So is the idea with the top surface, I mean, something like plastic, wouldn't it be fairly uniform throughout? Like,
yeah,
the surfaces, the surface, like the base,
yeah,
we would call the surface, correct? Is like the same as the subsurface, but then with like human skin or something like that, obviously
it's nutty.
You have skin tone, and
yeah,
then you have guts.
Yeah, it's nutty under there. Yeah, exactly. I mean, and people map all that. You know, they literally, when they make a really good skin shader, it's broken out into, you know, the dermis, the subdermis, and blah 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 blah. You know, because, you know, that's when you see them. when you see a bad, or you see a movie where something isn't quite right, it's probably somebody who doesn't know how to make a good surface shader or animate or composite. But you know what I mean? Like when something looks off, lots of times, it's like, that whole uncanny valley thing where people really know when something doesn't look right with a face. You know it because you stare at faces all day, or you know human faces, and that's why they go through all that work. So that's why these things are in there. I mean, the Arnold shader actually doesn't do the multiple levels that other ones do. Like I said, some shaders will break out all those layers, so when a light, they can actually tint light as it goes through different, 3 millimeters into the skin, do this and blah, blah, blah. And those are specialized shaders. This is really just more about putting a little bit of light moving through things like plastic, or once again, like the milk and all these kind of liquids and stuff like that, so that the thinner they get, the thinner it appears and all that stuff. So a mixture between this, a mixture between this and a bit of transmission really gives a really, really nice surface, so that you're making it just the tiniest bit translucent, but you're leaning on the subsurface to do a lot of the work. So, okay, so anyway, so like I said, what we really talked about today was just the contribution between shine, the base surface, and then going inside the object from, transmitting all the way through it to transmitting part of the way through it, okay? And that's a lot of what we need to worry about when you talk about the, almost any surface, because that's what they're made up of. Whether light is bouncing off of it, whether it's really bouncing off of it as in a reflection, how it's bouncing off, what colors you're getting out of it, and whether light is penetrating it and going through it, and how you're seeing that. That's how every surface is made, really. It's just when you look at objects, you'll start to see these things, and when you know how to use them, you can make obviously any surface you need to. It's just being aware that how much of it is reflection, how much of it is refraction, and how much of it is sort of bouncing around inside through the object, And yeah, that's it. So what we're going to do Wednesday is try and make a set of these, a lot of these ourselves, and we're going to do some examples, and we're going to do them here in class, and walk through those, and then we'll eventually move on to this is the bulk of the things that you really need to worry about in most shaders. There's some other extras that we'll be able to cover pretty quickly, but luckily this is a lot of what we need to talk about. Because these are the tools that you use to put together most surfaces. So, we've covered a lot of them, so that's pretty cool. So, like I said, stay with your Arnold standard surface shader. Stay away from your blends and your Lamberts and your Fongs and all that stuff. Just go to the Arnold, learn the Arnold surface shader for now, and you'll be a lot happier with what you get out of your renders. Thank you, guys.
Mhm.